2026 A-Level Combined Mathematics Paper 1 Part B Question number 12 Part B. Part A of the same question was discussed in a previous video, link in the top right. Part B of this question has to do with finite and infinite series. The question says, first off, find the real constants a, b and c such that the expression r plus 5 divided by r plus 1 times r plus 2 times r plus 3 is equal to a divided by r plus 1 plus b divided by r plus 2 plus c divided by r plus 3 for all r elements positive integers. So basically, break this expression into these three partial fractions. The question then says in the second part, let u of r be equal to the same expression of r plus 5 divided by r plus 1 times r plus 2 times r plus 3 for all r elements positive integers, and then says, let the function f of r be equal to 1 over r plus 2 for r element of the positive integers union 0. So that means the set 0, 1, 2, 3 and so on and so forth until infinity. Now given this, the question then says, using the result in part 1 above, show that u of r is equal to 2 times f of r minus 1 minus 3 times f of r plus r plus 1 for all r elements of the positive integers. The question then says, hence, show that the sum from r equals 1 until r equals n of u of r is equal to 2 over 3 minus 2 over n plus 2 plus 1 over n plus 3 for n element of the positive integers. Now, it's not given in the question, but that is a required condition. The question then says, show that the infinite series from r equals 1 up to infinity of the sum of all terms of u of r is convergent and find its sum, and finally it says find the value of the limit as n approaches infinity of the expression here, which is the sum from r equals 2 until n plus 2 of u of r plus the sum from r equals n plus 1 until 2n of u of r. Now to start with this question, let's write down this expression on the left hand side and right hand side and try to do the same thing that we do with partial fractions to find the values of the constants a, b and c. So writing this down, we have r plus 5 divided by r plus 1 times r plus 2 times r plus 3 on the left hand side, and on the right hand side we have a divided by r plus 1 plus b divided by r plus 2 plus c divided by r plus 3 for r element of the positive integers. Now for this, what we have to do first is to multiply everything by the denominator r plus 1 times r plus 2 times r plus 3. Doing so, we can see on the left hand side we are simply left with r plus 5, and on the right hand side we are left with a times everything except for r plus 1, which is r plus 2 times r plus 3 plus b times everything except for r plus 2, which is r plus 1 times r plus 3 plus c times everything except for r plus 3, which is going to be r plus 1 times r plus 2. Now simplifying this down, we can see on the left hand side we have 0r squared plus 1r plus 5 equals, and on this side we have a, b and c terms all giving r squared like this, this and this, and therefore we factorize, we'll have a plus b plus c r squared, and then considering the next two terms we have a times r times 3 and a times 2 times r for a total of 5ar. So we have plus 5a times r, and considering b we have b times 1 times r and b times r times 3 for a total of 4br, so therefore plus 4b, and for c we have c times r times 2 and c times 1 times r for a total of 3cr, so plus 3c all times r. 3c all times r. And for the constant terms, we have a times 2 times 3, which is 6a, so we have 6a, and b times 1 times 3, which is 3b, and c times 1 times 2, which is 2c on the right hand side. Now considering the coefficients here, we can say from r to the k terms, if we consider k equals 1, or rather k equals 0, k equals 1 and k equals 2, we can derive equations based on the fact that the polynomial on the left hand side is identical to the polynomial on the right hand side. So from the r equals 0 terms, which are the k equals 0 terms, which are the constant terms, on the left hand side we have 5, and on the right hand side we have 6a plus 3b plus 2c. Similarly, for the k equals 1 terms, which are the constant terms, or rather r to the power of 1 terms, we have 1 on the left hand side, and on the right hand side we have 5a plus 4b plus 3c as the coefficients. So 5a plus 4b plus 3c as the coefficients. And finally, for the k equals 2 terms of the r squared terms, we have 0 on the left hand side, and on the right hand side we have a plus b plus c. I'm going to call this equation 1, equation 2, and equation 3, and we'd use these three in order to find the values of a, b, and c. Now immediately what I can do is to try and subtract 1 and 2. So if I do 1 minus 2, I can see on the left hand side we're going to get 5 minus 1, which is going to be equal to 4. So we get 4 on the left hand side, and on the right hand side we have 6a minus 5a, which is going to be a, so therefore we get a. We have 3b minus 4b, which is minus b, and then we have 2c minus 3c, which is minus c. Now as we know, since a plus b plus c is equal to 0, if I rearrange this as 4 equals 2a minus a plus b plus c, we can see from equation number 3, we will get 4 equal 2a, as this part right here is equal to 0, and therefore we get the value a equals 2. Now after we get a equals 2, we can go back and try to substitute using the other ones another value to get b and c. So for this, what we can do is to try and take this equation and substitute in a plus b plus c equals 0. So here we can see we have 3 a's inside of this, we have 3 b's inside of this, and we have 3 c's on the other side. If I extract them, I can see from equation number 2, I can get on the left hand side 1 equals 2a plus b plus 3 times a plus b plus c. And if we substitute in equation number 3 here, we can see this is going to give us 1 equals 2a plus b. Now substituting the value of a, we can see we get 1 equals 2 times 2 plus b, and therefore b equals 1 minus 4, which is negative 3. So we get b equals negative 3. Now finally, we can substitute the values of a and b into one of these expressions in order to get the value of c. So I'll take equation number 3 since it's the easiest. So taking equation number 3, we can see we get 0 equals, and on the other side we have a plus b plus c. So a is 2, b is minus 3, and c is c. So we get 2 plus b, which is minus 3, plus c, and if we rearrange, we can see we have minus 1 here, taking another side is plus 1, and therefore c is equal to 1. And from this, we get on the left hand side r plus 5 divided by r plus 1 times r plus 2 times r plus 3 being equal to the partial fractions of a divided by r plus 1, which is 2 divided by r plus 1, plus b divided by r plus 2, which is going to be minus 3 divided by r plus 2, and finally c divided by r plus 3, which is going to be plus 1 divided by r plus 3. And that is the end of the first half of the question. Now the second part, which is the larger part, says let u of r be equal to this expression for all r element positive integers, and it also says let f of r be equal to this expression for r element positive integers union 0. Now writing these two down, we can see if u of r is equal to this same expression of r plus 5 divided by r plus 1 times r plus 2 times r plus 3, and we have this new function f of r, which is equal to 2 over, or rather 1 over r plus 2 for both. Actually, we have to write separately since this one has one condition, which is r element of the positive integers, and this one has the condition for r element of the positive integers union 0. So union the set of 0. Now for this, what we can do is to directly substitute this expression and say therefore u of r can also be written as 2 over r plus 1 minus 3 over r plus 2 plus 1 over r plus 3 for r elements positive integers. Now from this, in order to get the expression that we want, we need to convert each of these three partial fractions into the form that contains a 1 over r plus 2. So here what I'm going to do is to take the first term here, which is divided by r plus 1, and I'm going to rearrange it into 2 divided by r minus 1 plus 2. So now we have something plus 2. And similarly for the next term, I'm going to leave as is, as 3 divided by r plus 2. But for the last term, I'm going to write it as plus 1 divided by r plus 1 plus 2. And now we can see this divided by r minus 1 plus 2 can be written as f of r minus 1. And therefore we can write this as being equal to 2 times f of r minus 1. The next term, however, is just minus 3 times f of r, since f of r is equal to 1 over r plus 2, so we can just directly write minus 3 times f of r, and the last term can be written as f of r plus 1. Since if you substitute r plus 1 into f of r, you will get r plus 1 and the numerator plus 2. So this is what we get, and we can see this is exactly the expression that they asked us to find in the question. So with that, we are done with that first part of the question. Now after this, the next part of the question says, hence show that the sum from r equals 1 up to n of u of r is equal to 2 over 3 minus 2n plus 2 plus 1 over n plus 3. Now for this, what we have to do is to go down and use this expression inside of sigma. So I'm going to write u of r equals this expression, which actually I'll just copy it down. We just copy it down, this expression, and from this, if I take the sum of terms of the left hand side, it should be equal to the sum of terms of the right hand side. And therefore I can say, therefore sigma r equals 1 up to n of u of r is equal to sigma r equals 1 up to n of all of these terms of the right hand side. So I can just copy this down and put this inside of the sum, like so. Now with this, what we can do is to take each of these term wise, and we will see this sum will turn into telescoping sum. Some of the intermediate values will get cancelled out. So to do that, I'm going to consider r equals 1, r equals 2, r equals 3, and maybe r equals 4. And going down on the other side, on the maximum side, I'm going to consider r equals n minus 3, r equals n minus 2, r equals n minus 1, and r equals n. And for these values, I'm going to write down what the left hand side of the sum is equal to and what the right hand side of the sum is equal to. So on the left hand side, we just have the values of u of 1, u of 2, u of 3, u of 4, and going down over here we have the sums u of n minus 3, u of n minus 2, u of n minus 1, and u of n. Now on the other side of these equations, we have a bunch of terms in terms of f of r. So writing each of those down, we can see on top we have f of r's when r is equal to 1. So we'll have 2 times f of r minus 1, which is 1 minus 1, which is 0. So 2f0, minus 3 times f of r, which is f of 1. So minus 3f1, and then plus f of r plus 1, which is f of 2. Now on the next line, we'll have those same values when r equals 2. So we're going to have 2f of r minus 1, which is 2 minus 1, which is 1, minus 3 times f of r, which is f of 2, plus f of r plus 1, which is f of 3. Now for the next one, we're going to have 2f of 2, minus 3f of 3, plus f of 4. And for the next one, we're going to have 2f of 3, we're going to have minus 3f of 4, and we're going to have plus f of 5. Now on the other side, for the last term, we're going to have the values when r equals n, which is going to be 2f of n minus 1, minus 3f of n, plus f of n plus 1. Now the term before that is going to be what we get when you get r equals n minus 1, which is going to be 2f of n minus 2, since we have f of r minus 1, which is n minus 1 minus 1, and then minus 3f of n minus 1, plus f of n. Now term before that's going to be 2f of n minus 3, minus 3f of n minus 2, plus f of n minus 1. And the next term is going to be 2f of n minus 4, minus 3f of n minus 3, plus f of n minus 2. Now, if we take a look at the top, we can see, while the terms don't immediately seem to cancel, if you consider the f of 2 terms, we can see this f of 2 and this 2f of 2 will cancel with this minus 3f of 2. So this and this will cancel out. Furthermore, if you consider next diagonal, this 2f of 3, this minus 3f of 3, and this plus f of 3 will cancel out along this diagonal. And that will continue down on these long diagonals like this all the way down. Now on the other side, we can see at the very bottom, this 2f of n minus 1, this minus 3f of n minus 1, and this plus f of n minus 1 will cancel along the same diagonal. And similarly, the next terms up here will cancel like so. These terms will cancel, and these terms will cancel all the way up. So after these cancellations, we can see we're left with these three terms on top and these three terms on the bottom. And out of these three, we can see there's still some more cancellations. This 2f of 1 and this minus 3f of 1 cancel to give us just a single f of 1. And similarly, these two cancel to give us just a single minus f of n. So if we take all of these and we add the left hand sides and right hand sides like so, on the left hand sides, we are just going to have the sum from r equals 1 up to n of u of r. But on the right hand side, we can see we have 2f of 0, 2f of 0, and then we have minus 3 of 1 and plus 2f of 1, which is going to lead to minus f of 1. So we have minus f of 1, and then on the other side, we have minus 2f of n and a single f of n plus 1. So we have minus 2f of n plus f of n plus 1. And now, to find the expression that we had in the question, all we have to do is to substitute in f of 0, f of 1, f of n, and f of n plus 1. So doing so, we can see, since f of r is equal to 1 over r plus 2, the first term here is going to be equal to 2 times 0, or rather 1, divided by 0 plus 2. The next term here is going to be equal to 1 divided by 1 plus 2. The term after is going to be equal to minus 2 over n plus 2. And the last term here is going to be equal to 1 over n plus 1 plus 2. Now, simplifying this down, we can see the first term here is 2 times 1 over 2, which is 1, and the second term here is 1 over 3, so we get 1 minus 1 over 3, which is going to be 2 over 3, and then we have minus 2 over n plus 1 and n plus 2, and then plus 1 over n plus 3. So we get plus 1 over n plus 3, which is the final answer to our question. So we can write sigma r equals 1 up to n of u of r equals this expression right here. Now, after the question then says, show that the infinite series sum of r equals 1 up to infinity of u of r is convergent and find its sum. Now, we can do that by simply realizing that the sum to infinity is simply the limit of the sum up to n as n approaches infinity. So therefore, going down, we can say limit, or rather we can say instead first sigma r equals 1 up to infinity of u of r equals the limit as n approaches infinity of the sum from r equals 1 up to n of u of r, and then we can apply the limit to the actual expression of the sum from r equals 1 up to n of u of r. So that expression is this value right here. So I can directly copy that down and say the value of the sum to infinity is simply equal to the limit as n approaches infinity of this expression right here. So you can put that here and close the bracket and apply the limit of n approaches infinity into this expression right here. Now the first term is a constant, is 2 over 3, and therefore nothing happens as n approaches infinity. So we can just write 2 over 3. The next term is minus 2 over n plus 2, and as n approaches infinity, the denominator here approaches infinity. So therefore we have 2 divided by a very large number, which is going to approach 0. So this term approaches 0. So we have minus 0. Now the next term is also having a denominator of n in it, and therefore as n approaches infinity, this denominator approaches infinity, and therefore the whole term approaches 0. So we have another equals 0. And therefore if we cancel these two, we are left with the sum of 2 over 3. Now from this, since the infinite sum here is equal to a finite value of 2 over 3, we can say the infinite sum of sigma r equals 1 up to infinity of u of r is convergent. And we can also say, and the convergent sum is the value that we found, which is 2/3. And with that, we are done with that part of the question as well. Now we can move on to the last part of the question, which says, find the value of the limit as n approaches infinity of this whole expression on the inside here. Now before we do anything, let's write this down in our answer sheet, and then we'll try to figure out how we can tackle it with the information that we know so far. So what we have to find is to find the limit as n approaches infinity of the value of the sum as r equals n, or rather r equals 2 up to r equals n plus 2 of u of r plus the value of r equals n plus 2, or rather n plus 1 up to 2n of u of r. So going down, we can write that as being equal to the sum from r equals n plus 1 up to 2n of u of r. Now here, the first thing I'm going to direct your attention to is that if instead of these two limits, our sum had the limits of sigma r equals 1 up to r equals n of u of r, and we had the other sum, which is sum from r equals n plus 1 to 2n of u of r, these two terms are the sums of all of the terms of u of r from r equals 1 up to n and n plus 1 up to 2n, which means they are the sum of all terms u of r from the starting value of r equals 1 until the ending value of r equals 2n. So therefore, these two could be combined into the single sum from r equals 1 up to 2n of u of r. Now what's preventing us from doing that right now is the fact that the starting limit is not r equals 1 but rather r equals 2, meaning that the sum here is missing the term r equals 1, and also the fact that the ending term is r equals n plus 2 and not r equals n. So therefore, our sum here is missing the last, or rather has additionally the last two terms of r equals n plus 1 and r equals n plus 2. So due to this, what I'm going to do is to take this limit, I'm going to take it as the limit as n approaches infinity of, and on the inside, I'm going to turn this thing into the sum from r equals 1 up to r equals n of u of r, and to do that, I had to additionally add the term of r equals 1, and therefore I have to subtract the term of u equals 1, so r equals 1, so u of 1, and then since I also remove the terms when r equals n plus 1 and r equals n plus 2, I had to add them separately as u of n plus 1 and u of n plus 2, and to that I can add the last term, which is the sum from r equals n plus 1 up to r equals 2n of u of r. Now with this, what I can do is to rearrange this and write as the limit as n approaches infinity of, and I'm going to write this sum and this sum close together as the sum from r equals 1 up to n of u of r plus the sum from r equals n plus 1, the very next term, until 2n of u of r, and then I'm going to write separately the last three terms of the limit as n approaches infinity of minus u of 1 plus u of n plus 1 plus u of n plus 2. Now what I'm going to do is to write this bit first as the limit as n approaches infinity of the sum, which is the common sum from r equals 1 all the way up across all of the terms until n, and then all of the terms from n plus 1 all the way up to 2n as the sum all the way up to 2n of u of r, and then to that we're going to add these terms, which here, since u of 1 is a constant with respect to n, we can write it as minus u of 1 plus the limit as n approaches infinity of u of n plus 1 plus the limit as n approaches infinity of u of n plus 2. Now considering these, the very first term here is equal to the sum from r equals 1 up to infinity of u of r. The reason for that is that as we take n approaches infinity, 2n and n both approach infinity, and therefore taking the sum from r equals 1 up to n or r equals 1 up to 2n is the same thing. And therefore the first term here is equal to the sum from r equals 1 up to infinity of u of r. Now the second term here is the value of u of r when r is equal to 1, which is going to be equal to r plus 5 or 1 plus 5 divided by r plus 1, which is 1 plus 1, times r plus 2, which is 1 plus 2, times r plus 3, which is 1 plus 3, and then we have the other terms, which are the limit as n approaches infinity of n plus 1, which is going to be equal to the limit as n approaches infinity of, if you put n equal n plus 1 here, we're going to have n plus 1 plus 5 divided by n plus 2 times n plus 3 times n plus 4. And then for the last term, we're going to have plus the limit as n approaches infinity of n plus 2 plus 5 divided by n plus 3 times n plus 4 times n plus 5. Now here we can see the very first term is equal to the infinite sum that we had up here, which is 2 over 3. So if we substitute that, we have 2 over 3, and then we have 6 divided by 2 times 3 times 4. So cancelling these two, we can see this cancels to give us 1 divided by 4. And therefore the answer here is 2 over 3 minus 1 over 4 plus this limit, which we can see the order on the top is 1, but the order in the denominator is equal to 3, and therefore as we take n approaches infinity, this is going to approach 0. Now similarly, the second term here is also going to approach 0, as on top we have order 1, but on bottom we have order 3. So therefore, both of these limits approach 0, and we can write plus 0 plus 0. Now simplifying that down, we can see we have 2 over 3 minus 1 over 4 only, and if we take the common denominator of 12, we can write 4 times 2 minus 1 times 3 divided by a common denominator of 12. And simplifying down, we can see we have 8 minus 3, which is 5 over 12. And therefore, the final value of this expression that they gave us at the start here, sum from r equals 2 up to r equals n plus 2 of u of r, plus the sum from r equals n plus 1 up to 2n of u of r, is simply equal to 5 over 12. And with that, we are done this question. Now finally, let's go up and discuss the marks awarded for this question. So at the start of the question, when you take the expression given and rearrange it and get these three equations in terms of the constant terms, the r terms and the r squared terms respectively, for getting these three equations, you get 5 marks each for a total of 15 marks. Now after that, when you then use these equations to find the values of a, b and c, or you substitute them back into the original expression like so to get this equation right here, for getting that, you get 10 total marks. Now after that, when you're given u of r and f of r, and you take u of r and substitute in instead of this expression right here, and then rearrange each of these three terms into the form that contains f of r minus 1 in the first one, f of r in the second one, and f of r plus 1 in the third one, you get 5 marks. And then when you take this and substitute in f of r minus 1, f of r, and f of r plus 1 to get this expression right here, you get another 5 marks. Now after this, when you then consider the sum, for writing out the first few terms of r equals 1, r equals 2, r equals 3, you get 10 marks. Now here, you don't actually need to write the fourth term, 3 is enough. Similarly, when you write the last 3 terms at least, you get another 10 marks. Now from this, when you add the left hand side and right hand side separately and cancel all the terms here and get this expression on the right and this on the left and simplify down to get the sum from r equals 1 up to n of u of r equals 2 over 3 minus 2 over n plus 2 plus 1 over n plus 3. For all of this work, you get 10 total marks. Now after that, in the next part, when you then consider the sum from r equals 1 up to infinity and write it as being equal to the limit as n approaches infinity of sum of r equals 1 up to n of u of r, for writing like this, you get 5 marks. After that, when you substitute, apply the limit, simplify, and get 2 over 3 as the answer, you get another 5 marks. And finally, when you then conclude that the infinite sum sigma r equals 1 up to infinity of u of r is convergent and say that the convergent sum is equal to 2 over 3, writing the statement gets you another 5 marks. Now after that, when you're then given this thing as a challenge and you take this first sum and break it into this sum from r equals 1 up to r equals n of u of r, and these three extra terms of the minus u of 1 and the plus u of n plus 1 and plus u of n plus 2, for breaking these terms like this, you get 10 marks. After that, when you then take this sum and add them together separately, take these three terms and add them together separately, apply the limit to each of them separately to get this limit and all of this stuff, and then simplify to get each of these values. For getting these values correctly, you get 5 marks, and then after adding them together, when you get the final answer of 5 over 12, you get another 5 marks. And that is the end of this question. Now it should be noted, since the marking scheme is not available currently, the actual answers here could be slightly different and the marks awarded would also be slightly different. However, as an average, this is quite good. So anyway, that's the end of this video. I hope you enjoyed. If you have any feedback, post them in the comments down below. Thank you for watching and goodbye.